Welcome to this explainer. Right now, we are in the middle of an absolute paradigm shift in software engineering. We're stepping away from the traditional manual grind of writing syntax line by line and diving into the incredibly fascinating world of managing autonomous AI systems. If you've been tracking developer tools lately, you already know things are moving fast. But the underlying structural shift we're about to look at is way bigger than it seems. For a while, we were honestly stuck in generations 1 and 2, which were basically just about accelerating our typing. We had line-by-line autocomplete or chat windows that needed constant human handholding for every single step. But take a look at Generation 3. We are now deploying autonomous agents. These aren't just autocomplete engines anymore. They're entire command line harnesses that can observe an environment, plan out steps, and execute complex multi-file refactors entirely on their own.
It's a profound shift. And it forces us to ask a pretty massive question. What actually happens when developers stop typing code and start managing digital workforces? When your role elevates from an instruction-level coder to a system-level orchestrator, everything about how you plan and govern your work has to completely transform. So here is our roadmap for today. We'll quickly hit the AI engineering paradigm shift, dive into precision grounding and context, explore multimodal visual verification, map out multi-agent orchestration topologies, and finish up with your new role as the future systems architect. Starting right off with Section 1, the AI engineering paradigm shift. Let's look under the hood at how a modern terminal agent processes a request. When you give a complex command to an autonomous CLI agent, like migrate the auth middleware to JWT and write unit tests, it doesn't just blindly stream code. Instead, it loops through a highly precise sequence: observe, plan, act, and verify. First, it observes by assembling context. Then, it plans by generating structured artifacts. Only then does it act by invoking tools. And finally, it verifies. If a test fails, it feeds that error right back into its context and self-heals until things pass. And to pull that off, these agents have to be ruthless with their memory efficiency. By using techniques like deferred tool loading during the planning phase, the system can save over 190,000 tokens of context. To put that in perspective, that's a massive optimization that prevents dangerous memory decay, so your agent never forgets your original architectural constraints during a marathon debugging session. Which leads us perfectly into Section 2, precision grounding and context. Because if your agent operates autonomously, ambiguity is your absolute worst enemy. We really need to contrast the uncertainty of semantic vector search with direct path targeting. Semantic search can be great, but often it hallucinates and pulls in totally noisy, unrelated junk. Now picture this for precise workspace grounding. Imagine typing an @ symbol in the terminal and seeing a glowing, direct line extend across a 3D folder tree, anchoring directly onto a specific file. By doing this, you establish exact operational context and completely eliminate those search hallucinations. The agent knows exactly what to look at, no guesswork involved. This is what we call declarative system anchoring. By injecting context directly, you're laying down rigid architectural rules and forbidden anti-patterns that act as the agent's absolute boundaries. It ensures that the agent shares the exact same operational picture of the system as you do. Moving on to Section 3, multimodal visual verification. This is where things get incredibly futuristic. You really have to wonder, if these autonomous CLI agents operate primarily in a headless, text-based terminal, how on earth do they see and fix visual front-end bugs? To demonstrate this multimodal grounding, let's look at the proof sequence. The agent literally uses a headless browser to capture a screenshot of a broken UI layout. But then it goes a step further and overlays a visual wireframe coordinate map right on top of it. It uses this map to precisely locate the exact alignment bugs on the page, compares the coordinates to the expected design, and then iterates automated repairs until it's pixel perfect. It is quite literally seeing the interface. And this completely transforms the development process. We're moving away from digging through ephemeral logs, where raw standard output just dumps text and pollutes your context window, and moving toward versioned artifacts. The agent generates structured implementation plans, test summaries, and actual before and after screenshots as verifiable proof of work. Section 4, multi-agent orchestration topologies. Because once you've got a reliable agent, it's time to scale up. You essentially become an architect of a digital organizational chart, and you have choices.
You might use a hierarchical topology, where a central leader delegates isolated tasks, perfect for enterprise feature development. Or maybe a horizontal topology, where specialized peer agents discuss a complex bug in a shared thread. You even have blackboard systems, where asynchronous agents continuously monitor and update a shared global state. But to stop these parallel workers from just destroying each other's progress, the system heavily relies on Git worktree isolation. By sandboxing these subagents into separate branches, multiple agents can refactor totally distinct components at the exact same time without causing any file write conflicts. Which brings us to our final section, Section 5, the Future Systems Architect. If the agents are writing the code, what is your job? Well, it revolves around these core operator competencies. You have to master intent articulation and declarative constraints. You need to manage context window decay. You'll be the one setting loop bounds and circuit breakers so things don't spiral out of control. And of course, you'll be designing those topologies and connecting external model context protocol, or MCP servers, to hook these agents into your enterprise APIs. Take a look at this quote. The role of the developer is shifting from direct line-by-line code generation to intent definition, architectural constraint specification, and cognitive agent supervision. I think that completely hits the nail on the head for this entire explainer. Your real value is no longer in typing syntax, but in governing cognitive workflows. So I want to leave you with this vital question as you step into this next frontier of autonomous software engineering. As abstractions elevate from instruction-level coding to system-level orchestration, how will you govern your future digital workforce? Mastering these concepts is absolutely the first step. Thanks for joining me on this explainer. I hope it was a game changer for you.